Welcome to Study Loop.
In this problem, we are given that there is a block, and this block is initially at rest, and the mass of this block that is given as 5 kg, and this is pulled in the right direction along the surface which is horizontal with a constant force of 17 newtons. And we are required to determine the speed of this block right after it has moved 3.5 meters. So let's consider the speed as v, and here we are given the coefficient of the kinetic friction as 0.17. So here we will apply work energy theorem, and we see that the net work which is done is by this applied force and the work done against the friction. So friction force, well, that will be the coefficient of friction times the weight, because that would be the normal force. So the weight is mass times acceleration due to gravity. And to compute the work, we'll use this formula according to which work is force times distance. So here we just add the total work. So the work done by the applied force is 17 times 3.5. And from this, we subtract the work done against the friction, which is the friction force times the displacement, and this is equal to the net change in the kinetic energy. So it is just the final kinetic energy, because initially it was at rest, so it's half into m into v square. So here we just multiply 17 with 3.5, and from this we subtract 0.17 times 5 times 9.8 times 3.5, and we multiply this with 2 and divide this with 5, and then we take the entire root of this expression to get V as 3.5 meters per second approximately. And that's the answer.